So we're going to do egg, which is an int list problem that wants us, given this int list, to run these statements through the int list and then output what the int list is going to look like after statements A through E have been run in the correct order. So first, we should make a really big clarification about references and pointers. This is kind of a refresher for you. But here I've drawn two representations of what this could be. So I have a representation of egg being this box. So egg is a variable, and I treat variables as like boxes with labels. You can put things in them. So egg, and this is example 1, this is example 2. So egg, in this case, is just a box that holds a reference to the int list instance. And this is the correct understanding, because egg is a box that holds a reference. Unlike the second example I have drawn, where egg is a box that holds the entire int list, like chain. And this is wrong, because all egg is doing, like egg is just a 32-bit pointer or 64-bit pointer to an int list class. So it's really important to know that egg is just holding this like arrow. Egg is not holding like all of these int lists instances inside its own box. Those exist like on their own in space. So that's a big difference you should know so that you don't get tripped up on these kinds of problems. So yeah, egg holds a reference, not the entire int list. So when I'm doing these kinds of problems, I'm going to draw out my own diagram of what egg is pointing to so that I can make changes to it as needed. So we'll say H and T for head and tail. So 1. So we've drawn the entire list that they've given us. So now let's run through statement A. So statement A is giving us this for loop, and this for loop effectively in every iteration of the for loop is moving egg.tail, so it's reassigning egg.tail to be egg.tail.tail. So before we jump into how many iterations the for loop does, let's figure out what this assignment is doing. So remember, whenever we're doing an assignment, the right-hand side gets evaluated before any assigning occurs. So egg.tail.tail evaluates to what? Well, let's follow the pointers. So egg holds a reference to this int list instance. And this int list instance is tail, so this is the first tail, so this is egg.tail, is pointing to this int list instance. So we have one level of egg.tail, but then what is egg.tail.tail? Well, it's this instance, this int list instance, this is tail, which is pointing here. So this is egg.tail.tail. Now this is where my refresher comes into play, because for a really common misconception on these kinds of questions is that we would move like a pointer to point at this specific box. But this specific box is actually just holding a reference to the next int list instance. So egg.tail.tail is actually here, and it's not here, because egg.tail.tail, when you evaluate it, it evaluates to like an address to the next location of this int list instance. So this is egg.tail.tail. That is what it evaluates to. And egg.tail evaluates to this. But because we're making an assignment on egg.tail, you're telling this tail to now point here instead of here. So then this pointer is going to go away. So that is just going through what egg.tail equals egg.tail.tail. That's what it does. Effectively, what it's doing is skipping over this item in the int list by telling this tail to point to the item that's one ahead of the next item. So knowing that, let's go over how many times we're going to do this sort of skipping behavior. So whenever you're faced with a for loop, it's a good idea to have a table of I and whether it passes the conditional. So I starts out at 0, and 0 is less than 2. So it's going to pass the conditional, and it's going to execute the body of the for loop. Now when we increment I by 1, so we go back to the start of the for loop, It's still less than 2, so this passes the conditional, and we're going to execute the body again. Now when we increment I by 1 again, 2 is no longer less than 2, so this is not past the conditional anymore. And we can just see by counting the number of checks that the body will execute twice. So that means we're going to skip pretty much 2 items ahead in our int list. So what does that mean? Well, let's do it. So let's do the first call of egg.tail equals egg.tail.tail. So now egg.tail is going to point here. So effectively, it's kind of like this thing is gone. There's nothing that's pointing to it, so eventually it'll actually get garbage collected. So for now, you can just treat it as, because there's nothing pointing to it anymore, we can no longer access this class or this object instance. So this was after the first iteration through our for loop. Now the next iteration is asking us to do the same thing. Egg.tail should now be egg.tail.tail. So we should be moving the pointer 1 ahead. And now, because there's nothing that's referencing this int list instance with 2 as the head, this is also kind of just gone for us because we can no longer find it ever again because we didn't save it in a variable. So this finishes statement A. Now statement B is telling us egg.tail equals new int list egg.tail.head minus 1, comma egg.tail. So that was a mouthful. And remember, we're going to evaluate the right-hand side. So egg.tail.head. What is egg.tail.head? Well, let's see. This is egg. This is egg.tail. And this is egg.tail.head, the 6 over here. So egg.tail.head equals 6. So you just follow the pointers. And 6 minus 1 is 5. And egg.tail is, well, pointing here. So effectively what we just did was make a new int list instance with 5 as the head and the tail as whatever egg.tail was, which it was pointing here. So now we have made this new int list, and I just erased that arrow because we're going to reassign egg.tail to be the new int list we just made. So now this is what our int list looks like now. This is what egg looks like. It's getting a little bit ugly, but it's okay. So let me make some space by erasing this. And this finishes statement B. So now let's run statement C. So statement C, what it's doing is initializing a new box to hold a reference. So this is not like making a deep copy of the list. So what's happening is that you have this box backup that pretty much copied over like whatever pointer that egg had. This was like egg's pointer. So this means that you're not going to make another copy of all of these int list instances. You're just going to copy the pointer. So let's do that. We're going to make backup. And we're going to copy this pointer. So we're just going to be pointing to this int list instance. So notice that no new int list instances were created. We just made a pointer to whatever egg was pointing to. And that was statement C. Now statement D says egg equals egg.tail.tail. Well, this is just reassigning this pointer to be whatever egg.tail.tail evaluates to. So what is that? Well, egg.tail.tail. So now egg is going to be pointing, so egg.tail.tail. So egg is going to be pointing here. Boop. And that's it for statement D. And then statement E says backup.tail equals egg. So what is backup.tail? Well, this is backup.tail. So we're going to change this pointer to be whatever egg is pointing to, which is right here. So again, an observation you should make is that now there's nothing pointing to this 5, so this new egg instance that we just made, so it's effectively gone. And I'm crossing these out because in the answer box, they're telling us do not include boxes that cannot be reached from either egg or backup. So now 5 can no longer be reached from egg or backup. Same with 9 and 2. So Now when we're filling out this answer, so we finished the statement, we just need 1664. So 1664. And now it's just pretty much copying over the diagram to the answer box. So 1 is pointing to 6, 6 is pointing to 6, and 6 is pointing to 4. And egg is pointing to the 6 box, so egg is going to be pointing here. And backup is pointing to the box with the 1 in it. And that's part A. Let's do part B, which is a little more trickier, so I'm not going to look at the solutions. I'm just going to walk you through my thought process as I go through this problem. So part B says rearrange the 5 statements so that after the execution is completed, there is some int list with exactly 4 elements, 1, 2, 3, 4. And to write your responses in the blank below, 1 letter per blank, and you can only use each letter once. So they're asking us to mutate this current int list, so this int list here, to become 1, 2, 3, 4. How do we do that? Well, this is sort of like a kind of like a logic question where it's like, how do we get our pointers to line up the way we want them to? So I think the easiest part we can start with is that at some point we're going to need an int list. We need to get an int list with 3. And you can have like whatever pointer here. And the reason I'm making this point is because all the numbers here are only 1, 9, 2, 6, 6, 4. And the only way we're going to be able to get an int list with 3 is to use statement B. So we have to use statement B. And then to use statement B to actually get an int list with 3 pointing to something, we have to make sure that egg.tail is equal to the int list with 4 in it. The reason I say that is because the only way you can get 3 is by subtracting 4 from 1, and the only way to get 4 is to make sure egg's tail is pointing to like this 4 box. So that's one thing. So now we just have to think about how do we get the 1, 2, and 3, and 4. So we know that 3 is going to be pointing to egg.tail. So at some point, egg.tail has to be pointing here so that we can use statement B to get like our 3 and our 4. So that means like statement B is going to come later because we have to move our pointer. Okay, so let's look at what else we have to do. Well, we also have to remove the 9. To remove the 9, that's like, we have to remove the 9 node because we want 1, 2, 3, 4, not 1, 9, 2, 3, 4. So the way we do that was some sort of egg.tail equals egg.tail.tail because that skips you 1 ahead. So let's look at what we can do. We have egg equals egg.tail.tail, which doesn't really do anything. It just moves your egg pointer. So we have to figure out how to get rid of this 9. So let's think about it. So the only way we can actually get rid of this 9 is to use statement A, right? But then statement A also gets rid of our 2. So what should we do about that? Well, we can say that we see that backup.tail equals egg, and then backup.tail will give you 9. Right, okay, if we set backup.tail to equal egg, we can effectively skip something. Yeah, so that means we actually can't use this statement because like this seems like the most obvious statement to use, but it's gonna move us, it's gonna like remove both of these, and we don't wanna remove both of these. So how else can we do that? Well, we can see that here we can set another tail to be something else. So if we can't use statement A, we have to use like either statement C, D, or E. So that's just a fact. And this pattern here is that we can set backup to be like egg. So let's just draw out 1, 9, and 2. So if egg is pointing here, we can set backup to point here. But then we can move the pointer of egg to be over here. And then we can set backup.tail to be here. And then effectively, we just got rid of the 9. So 1, 2. And this is going to come first because this statement, if we put this statement first, it wouldn't work because we would get rid of our 9 and 2. And then if we put this statement first, that wouldn't work either because right now our egg.tail is not pointing at the 4. The order of this is to first initialize a backup, and then to move our egg 2 forward so that we can set backup.tail to be 2 forward, which effectively skips the node with 9. So it's CDE, and now we just have to figure out, should statement B come before statement A? So let's look at the current state of our int list. It'll be 1, 2, and 6, 6, 4. Well, if we call B, what it's going to do is make a node here that's 7. Well, hold on, what is egg pointing to? Egg was pointing to egg.tail.tail, so egg was pointing here. So yeah, we would get a node with 7, and that's not what we want. Instead of getting 7, well, we want to get 4, so then that means we need to move our egg pointer, or we need to somehow get our egg so that its tail is 4. And we can do that using statement A, because what statement A did from part 1 was effectively skip like egg.tail by 2 nodes in the int list. So if we do statement A, then egg.tail is going to skip forward 2, just like how it skipped the 9 and 2 in part A. So that's going to skip the 6 and 6. And now we have our list set up in perfect position so that we can run statement B and create our intermediary 3 node here, and then assign egg.tail to be here. And that's problem B.